I'm interested in action reading. This is directly linked to CBMM questions. Who is doing what and what is happening next? The task is very simple. If you ask these questions while subjects are playing a simple game, you have two subjects sitting in front of each other. There are two targets in between them. One of the subjects is an attacker, picks one of the two targets, and the other subject has to block them. Means that they have to read out what that person is going to do and get there as fast as they can. This allows us to sort of see the process of action reading in real time. What we found out was that subjects are extremely fast, much faster than responding to a single dot moving on the screen, in the order of 90 to 100 milliseconds faster. Which means that before the subject moves their finger, in their body there is information giving away where they're going to go. To actually prove this, we had subjects videotaped. And in these videotapes, we systematically removed all of the frames of the movie right before their finger starts to move. The videos look nearly identical. One of these videos is manipulated and one of them is not. And when you do this and ask the subjects to sort of move their finger and respond to these subjects, to these videos, subjects are much faster in responding to the normal videos compared to the videos in which those very few frames is removed from the beginning. And the left one is the manipulated videos, if you're curious. So this proves that there is really a lot of information in the body about the actions and about the goal of the subjects before the movement happens. To sort of find out where this information is, we covered the subject's body with the pieces of cardboard. And surprisingly, we found that this fast reaction times are very resilient to covering different parts of the body. Subjects were pretty much fast in all of these conditions except for this one, which you can barely see anything. So this means that this information is actually distributed over the body of the subjects, which is not surprising given that we have a skeleton. Body parts are connected to each other. When you move one limb, you actually have to sort of make a lot of adjustment to the other body parts in order to sort of adjust your center of gravity and so on and so forth. So this is sort of a basic observation, but we want to move forward with sort of trying to address this question of where the information is in the body by running some image statistics analysis on the videos and sort of machine learning algorithms to try to pinpoint where the information is, and then using these image statistics to inform more systematic sort of online massive experiments so that we can sort of pinpoint where the body is informative with sort of behavioral paradigms and in the end comparing these machine learning algorithms with the behavioral performance of humans. And then using very similar paradigms, we would like to answer new questions such as whether or not humans can tell apart cooperation versus competition, and also add deception to the experiment to see whether people can tell whether somebody is fainting or actually going to the actual target in the end.